Welcome. What you are about to watch is not science fiction, and it is not folklore. It is a serious investigation into one of history's most compelling unresolved questions: the mystery of the Blood Falls of Antarctica, a red waterfall bleeding from a glacier for 100 years. Across the world, in universities, research institutes, and field excavations, serious scholars are wrestling with evidence that does not fit the accepted story. Evidence that has been documented, measured, and peer-reviewed, and that still has no satisfying conventional explanation. We are going to look at that evidence carefully, without prejudice in either direction. Not dismissing what is extraordinary, but not accepting it without scrutiny either. The truth, as always, is in the details. On the Taylor Glacier in Antarctica's McMurdo dry valleys, a waterfall of blood-red liquid pours continuously from a crack in the ice and flows across white snow into the frozen surface of Lake Bonney. It is approximately 5 stories tall. It has been flowing since at least 1911, when geologist Griffith Taylor discovered it during Robert Falcon's Scott's Antarctic expedition. Taylor assumed it was colored by red algae. He was wrong. For decades, the source of the red color and the origin of the water remained unknown. Scientists knew it was hypersaline, saltier than the ocean, and iron-rich, and that it flowed despite temperatures well below the normal freezing point of water. In the early 2000s, microbiologist Jill Mikucki drilled into the glacier and found what was producing it: a lake sealed beneath the ice for approximately 1.5 million years, completely isolated from the atmosphere, sunlight, and oxygen. The lake was full of living microorganisms, and what they were doing in that sealed, lightless, oxygen-free brine has made Blood Falls one of the most scientifically significant sites on Earth. This is where our investigation begins. Stay with us, because the further we go into the evidence, the more extraordinary it becomes. The story you think you know is only the surface. Beneath it lies something far more remarkable. Let us begin. Before we examine the specific evidence, we need to step back and understand the context. This case does not exist in isolation. It sits within the landscape of modern documented mysteries, and to properly evaluate what we are looking at, we need to understand the broader picture that surrounds it. Human perception is fallible. This is not an insult, it is neuroscience. The brain does not passively record reality, it actively constructs it, filling gaps with expectation, inferring causes from insufficient data, and storing memories that are reshaped by subsequent experience. Eyewitness testimony is the weakest form of courtroom evidence, precisely because what people see and what actually happened frequently diverge. Sound can cause visual hallucinations. Infrasound at specific frequencies can produce feelings of dread, the sensation of a presence, and even visual disturbances. Sleep deprivation, stress, and hypoxia can generate vivid experiences indistinguishable from waking reality. All of this is relevant when evaluating modern mysteries. Many apparently anomalous experiences have prosaic explanations rooted in human neurology: temporal lobe activity, hypnagogic hallucinations, shared social expectation shaping perception. A willingness to consider these explanations is not dismissiveness, it is intellectual hygiene. The brain is capable of generating extraordinarily convincing experiences that have no external cause, and yet the perceptual explanation has its limits. It cannot account for physical evidence: radiation burns, landing traces, electromagnetic interference on electronic equipment, or anomalous readings on calibrated instruments. When multiple independent witnesses, separated by distance, report identical details, mass hallucination strains credulity. When physical measurements corroborate subjective experience, the neurological explanation is insufficient. These are the cases that demand another look. This context matters because it tells us something important. What we are about to investigate is not an isolated curiosity. It is part of a pattern that researchers in multiple fields have been independently documenting for decades. And patterns, in science, demand explanation. With that foundation in place, let us now turn to the specific case at hand. Now we reach the heart of the matter. The core evidence surrounding the Blood Falls of Antarctica A red waterfall bleeding from a glacier for 100 years is more extensive, more verified, and more troubling for conventional explanations than most people realize. Let us walk through it systematically, fact by fact, and allow the evidence to speak for itself. We are not going to speculate here. Every point that follows is documented in peer-reviewed publications, official archaeological records, or government archives that are publicly accessible. The question is not whether these facts are real. The question is what they mean. Consider this first extraordinary detail. Blood Falls was discovered in 1911 by Australian geologist Griffith Taylor during Robert Falcon Scott's Terra Nova expedition. Taylor Glacier in the McMurdo dry valleys of East Antarctica, where the falls emerge, is named in his honor. Taylor noted the red color and initially attributed it to red algae, which was recorded in expedition reports without further investigation. The waterfall's true source was not investigated scientifically for nearly a century. This single data point, if taken in isolation, might be set aside. Anomalies happen. Instruments malfunction. Researchers make mistakes. But as we continue, you will see that this is not an isolated anomaly. It is part of a consistent and documented pattern. But that is only the beginning. Researchers also discovered the water emerging from Blood Falls is hypersaline, with a salinity approximately 3 times that of ocean water. This extreme salinity depresses the freezing point of the water to approximately -5 degrees Celsius, allowing it to remain liquid inside and beneath a glacier whose surface temperature is far colder. The water is also extraordinarily iron-rich, having dissolved iron from the bedrock over 1.5 million years of contact in the sealed subglacial environment. Now, a skeptic might propose an alternative explanation for this, and that is entirely reasonable. We should always test alternative explanations before accepting extraordinary ones. The problem is that the alternative explanations, when examined carefully, create more problems than they solve. The mystery deepens when we examine. Jill Mikucki, then at the Massachusetts Institute of Technology and later a professor at the University of Tennessee, led a research team that drilled into Taylor Glacier between 2004 and 2009 to locate and sample the source of Blood Falls. The team's drilling confirmed that the water originates in a subglacial brine pocket, a reservoir of hypersaline water sealed beneath the glacier and cut off from the atmosphere for an estimated 1.5 to 2 million years. This is where the conventional account begins to strain. Each individual fact might be dismissed or minimized in isolation. But the cumulative weight of the evidence is another matter entirely. Perhaps most remarkable of all, when the iron-rich brine from the subglacial reservoir contacts the air at the point where it emerges from the glacier, the dissolved iron undergoes oxidation, the same chemical process that produces rust. The iron oxide particles color the water red immediately on contact with oxygen. This explained the color definitively, disproving Taylor's red algae hypothesis. The oxidation happens so rapidly that the water is visibly red within seconds of emerging. Researchers who have examined this evidence have described it as genuinely difficult to explain within the accepted framework. These are not fringe commentators. They are credentialed academics publishing in mainstream journals, raising questions that the field has not yet satisfactorily answered. Then there is the matter of. Mikucki's team published findings in Science in 2009 confirming the presence of iron-oxidizing bacteria in the Blood Falls water. These microorganisms metabolize by oxidizing iron, using it as an energy source in the complete absence of sunlight and oxygen. 17 distinct types of microorganism were identified in water samples, forming an active ecosystem sustained by chemolithotrophy, chemistry-driven metabolism, in conditions previously considered too extreme to support complex microbial communities. What makes this particularly significant is its independence from the previous points. This is not a case of one theory requiring another. These are separate lines of evidence converging on the same uncomfortable conclusion. Adding to the enigma is this finding. The subglacial brine reservoir beneath Taylor Glacier is driven to the surface by pressure differential within the glacier. As the ice moves and flexes, brine is periodically forced up through a crack in the glacier face, producing the waterfall. The crack was confirmed by ground-penetrating radar surveys. In 2018, Mikucki's team inserted a specialized hot water drill to collect pristine samples from deeper in the reservoir, confirming the active microbial ecosystem and documenting the brine's extraordinary geochemical properties. Taken together, these facts form a pattern that cannot be explained by coincidence, misidentification, or methodological error. Each piece of evidence has been examined by skeptics. Each has been subjected to alternative explanations, and in each case, the alternative explanation falls short of accounting for everything that has been documented. We are left with a body of evidence that demands explanation and an accepted narrative that does not provide one. This is where serious inquiry begins. Now that we have established the evidence, we need to examine the theories that researchers have proposed to explain the Blood Falls of Antarctica, a red waterfall bleeding from a glacier for 100 years. This is where the debate becomes most intense, because the theories reflect not just different interpretations of the same evidence, but fundamentally different assumptions about what is possible and what the past looked like. Understanding these theories is not just an academic exercise. Each one has been championed by serious researchers with genuine credentials, and each one captures something that the others miss. The truth, if it is ever established, will likely draw on elements of several. The first major explanation proposed by researchers holds that Blood Fall's red color is caused by red algae living in the water. Griffith Taylor's original 1911 hypothesis, now definitively disproven. Mikucki's analysis confirmed no significant algal component in the water. The color is produced entirely by inorganic iron oxidation on contact with atmospheric oxygen. The hypothesis is retained here because it illustrates how long a straightforward observation can persist without rigorous investigation in a remote and difficult-to-access environment. This interpretation has significant academic support and is backed by substantial evidence. But it is not without problems. Critics point out that it requires assumptions that go beyond what the evidence strictly supports, and that key predictions of this theory have not been confirmed by subsequent research. It remains contested, and the contest is productive. A rival school of thought argues that iron-rich water from the subglacial reservoir oxidizes on contact with air, producing iron oxide particles that color the water red, the confirmed scientific explanation. The iron content of the brine results from 1.5 million years of contact with iron-bearing bedrock in the sealed subglacial environment. Mikucki et al. Confirmed this mechanism in peer-reviewed publications in 2009 and 2018. The explanation is complete, chemically consistent, and backed by direct sampling of the water source. This theory is controversial, and deliberately so. Its proponents argue that the evidence demands an explanation outside the conventional framework. Critics counter that extraordinary claims require extraordinary evidence, and that the evidence presented, while suggestive, does not yet meet that standard. The debate continues in peer-reviewed literature. Perhaps the most unconventional theory suggests that the sealed subglacial brine represents a model environment for life beyond Earth, specifically for the subsurface ocean of Jupiter's moon Europa and the subsurface of Mars. If chemolithotropic microorganisms can survive 1.5 million years of isolation in hypersaline, anoxic, iron-rich conditions beneath a glacier, analogous organisms could potentially persist in similar environments elsewhere in the solar system. NASA has adopted Blood Falls as a primary analog site for astrobiology research. What is striking about this debate is not merely that experts disagree. That is normal and healthy in science. What is striking is the quality of the disagreement. Serious researchers working from the same body of evidence, reaching genuinely different conclusions. That level of fundamental disagreement, when it persists over decades, is a signal that something important has not yet been understood. The question is not which of these theories is right. The question is whether any of them is right, or whether the truth is something that none of the current frameworks has yet been able to capture. The case surrounding the Blood Falls of Antarctica, a red waterfall bleeding from a glacier for 100 years, does not rest on speculation alone. What distinguishes this investigation from pure mythology is the existence of documented, physical, verifiable evidence, material that has been examined by credentialed researchers and whose authenticity is not seriously disputed. What is disputed is its interpretation. Let us review the most significant documented evidence as objectively as possible. We are not going to cherry-pick the data that supports a preferred conclusion. We are going to lay out what exists and let you draw your own assessment. Physical evidence supporting this account includes Mikucki et al. S. 2009 paper in Science, a contemporary microbially maintained subglacial ferrous ocean, confirmed through direct sampling that the Blood Falls outflow contains iron-oxidizing bacteria of the genus Thiomicrospira and related organisms. The paper documented water temperature, salinity, iron concentration, and microbial population, establishing the scientific baseline for the site. The 2009 findings have been confirmed and extended by subsequent sampling campaigns. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Investigators have documented the iron content of Blood Falls water was measured at levels consistent with 1.5 million years of bedrock dissolution in a sealed environment. Isotopic analysis of the water confirms its ancient origin and its long isolation from the atmosphere. The geochemical profile of the brine is consistent with the minerals present in the underlying bedrock geology of the Taylor Valley, providing an independent confirmation of the subglacial dissolution explanation for the iron concentration. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. On-site analysis revealed ground-penetrating radar surveys of Taylor Glacier confirmed the location and extent of the subglacial brine reservoir and the crack through which it reaches the surface. The 2018 hot water drilling expedition, led by Mikucki in collaboration with a team from the University of Alaska Fairbanks, collected brine samples from multiple depths within the reservoir and confirmed that the microbial community is actively metabolizing G throughout the reservoir, not just at the surface outflow. This evidence has been subjected to independent verification. Skeptics have examined it. Alternative explanations have been proposed and tested. The data remains. The question of what it means remains open. Each individual piece of evidence might, in principle, be explained away. A single anomalous artifact might be misidentified. A single anomalous date might reflect contamination. A single anomalous eyewitness account might reflect misperception. The question is whether all of the evidence can be explained away, and whether the explanations required are more or less plausible than the evidence itself. When multiple independent lines of inquiry converge on the same conclusion, that convergence is the most powerful signal in empirical science. And that is exactly what we are seeing here. We have examined the history, the evidence, and the theories surrounding the Blood Falls of Antarctica, a red waterfall bleeding from a glacier for 100 years. Now we need to ask the question that is sometimes overlooked in discussions of ancient mysteries. Why does this matter? What does it mean for us today? It would be easy to file this away as an interesting historical curiosity, a puzzle from a distant past with no bearing on our present lives. That would be a fundamental mistake. The questions raised by this case touch on issues that are directly relevant to who we are, where we came from, and what the human story actually looks like before the period covered by conventional history. Blood Falls is now a standard reference site in astrobiology and one of the best documented examples of chemolithotropic life in an extreme environment on Earth. NASA research into life detection strategies for Europa and Mars uses the Blood Falls ecosystem as a model for what subsurface life might look like and how it might be detected. Mikucki's ongoing research program continues to characterize the microbial community and its metabolic strategies. The site is remote, difficult to access, and not open to tourism. Scientific papers from Blood Falls research inform instrument design for future space missions, including planned Europa landers. The waterfall itself continues to flow, as it has for at least 115 years, red, cold, and carrying life from a world sealed inside a glacier. Furthermore, the tools available to investigate these questions are advancing rapidly. Satellite imaging, ground-penetrating radar, ancient DNA analysis, isotopic tracing, and deep-sea sonar are all providing capabilities that previous generations of researchers could only dream of. Cases that were genuinely unresolvable 10 years ago are now open to new analysis, and the findings, consistently, are expanding rather than contracting the mystery. The investigation continues. New discoveries are being made. New analyses are being published. New voices are entering the conversation from disciplines that were not previously part of the discussion. The answers, when they come, and they will come, will not merely solve a historical puzzle. They will force a fundamental revision of assumptions that underpin our entire understanding of human history and human potential. We have now walked through the complete case of the Blood Falls of Antarctica, a red waterfall bleeding from a glacier for 100 years, from the historical record, through the physical evidence, across the competing theories, and into the modern significance of what remains unresolved. What the story of Blood Falls ultimately reveals is not just a historical puzzle. It is a mirror. It reflects our assumptions back at us, our assumptions about what ancient people were capable of, about how knowledge is gained and lost across the centuries, and about the relationship between what we know and what we merely think we know. The evidence presented in this documentary is real. The questions it raises are genuine. The debate among researchers is ongoing, and that is healthy. Science is not a set of conclusions. It is a process. And the process requires that we remain open to evidence that challenges what we thought we knew, however uncomfortable that challenge might be. If you came to this documentary as a skeptic, we hope the evidence gave you something to think about. If you came as a true believer, we hope the critical examination gave you a more nuanced picture. The truth, as always, lies in the evidence, not in what we want to be true. Thank you for watching. If this investigation sparked your curiosity, please subscribe to the channel. We publish new documentaries every week, covering the full range of historical mysteries that the mainstream has not yet adequately explained. Leave a comment below telling us which case you want us to investigate next. The conversation continues. The investigation never ends.